Hi there. So this final video is mainly about tying up the loose ends and resolving minor issues that are with this project so far. So the first thing that I'd like to focus on is cancelling out these red operation nodes. So we're going to focus on the Flatland 2 operation first. And if we click on the operation and then hover the mouse over the node, it tells us what the error is, which is a contact with workpiece on rapid feed. So this is an issue that can be solved in the links menu. So if we go there now, and the two primary things here that I'm seeing that are causing me some concern. One is the link clearance height, and this is the height that's set for the tooltip to elevate by when it's moving across areas that it's already machined. 0.1 of a millimeter is rather small, so I'm going to bump that up to 2 millimeters, which is a little exaggerated, but you know, with the amount of interpolation that goes on with robot motion, the more we give it, the easier a time it has. And the other one is the safe distance, which is a sort of an XY coordinate issue, whereby it's only got 0.6 millimeters to be able to play with there, which is a bit on the small side. So I'm going to bump that up from 10% to 50%, which should give us 3 millimeters. And hopefully that should resolve the worst of those problems. So we're going to recalculate this now, and the unfortunate side effect of having to go back and do changes midway through is that it does affect every subsequent operation as well. So I'm going to very quickly recalculate everything just to make sure that everything is recalculated fully, because sometimes it does leave gaps. And subsequent to that, I'm going to take a look at the other two operations that were still coming up red after the simulation as well. So there's a few more red things coming up here, but none of this has been simulated since. So I'm fairly confident that most of those are invalid responses. However, the 2D Contour 1 and 2D Contour 2 operations were presenting us with problems. So if we take a look at 2D Contour 1, the first thing that I can see that's likely to cause us an issue is the fact that we don't have any kind of proper lead in or lead out, nor do we have any kind of plunge resolution. And if we hover the mouse over the red node, we can probably see that yes, contact with workpiece on rapid feed and the ramp angle is too high. So that means that we don't have any proper ramping enabled, and the contact with the workpiece on the rapid feed means that it just plows straight into where it needs to be cutting without any kind of lead in. So let's change that now. We can set the lead in. So if we set the engage lead in by arc, now 7 millimeters radius doesn't sound very big, but if we pan over to a top-down view and look, we can see that this radius is going to exceed the bounds of these smaller holes. So I'm going to set that radius to 3 millimeters instead, which is much tighter, but that should keep everything within its respective tolerance. We're also going to set a plunge on lead in. So I'm going to set the height of that plunge to 100%, which is 4 millimeters, just to give it a little bit extra to work with. I'm also going to increase the ramp angle quite drastically on this. Because these are quite small holes that they've got to work into, there's not a lot of space for a very low angle to come in. So I'm going to set it to near vertical, but not quite. So 75 degrees. And I'm also going to smooth the arc of that approach as well, so it's a 5 millimeter radius on there. Okay. Now, finally, there was one other thing that I spotted, which I'm hoping you should have caught as well. In this large cutout area here, the placement for this entry point is not great. Okay. It's going to cause us problems because it's going to try and arc out into the actual workpiece itself. So we're going to grab this and we're going to move it over to a straight area where it's got plenty of space to work with. And now we're going to recalculate all of the toolpathing for this. So if we regenerate that toolpath now, excellent, we should see that everything feeds in properly. So I'm going to copy these same settings over to the 2D contouring tool path as well, purely because I'm pretty confident that this should resolve the bulk of our problems. Excuse me. And it means that we've got a good starting point with no major differences between them if there is anything further that we need to address. So I shall very quickly do that now. So plunge on lead in, 100%, 75 degrees, 5 millimeters, with an engage by arc of 3 millimeter radius. And we now click on generate. Okay, that's all looking good. Yep. So, after all of that, what I'm going to do now is I'm going to regenerate all of the toolpaths for all of these operations, and then I'm going to run the simulation as well. And to save your time, what I'll do is I'll come back once the simulation has been run, so you can see the end result, and you can see that all of the nodes are green. Okay, so let's go back into a top view here so we can see everything clearly, and I'll catch you in a couple of minutes. Right, so now that we've come back, we can see that at the end of this simulation, every single node that's in here is green. So this is really good news for us so far. There are a couple of things that we still need to resolve. One is the sections that are internal that haven't been cut completely cleanly, although these are very easy to fix. And also there is this section here that hasn't been cut particularly well. Now, realistically, something that's a side face like that would ordinarily be handled as a secondary operation with a fresh new orientation. We can, however, clear off some of these weird spurs that are forming along the edge of the wall here. So if we turn on verify compare, they should come up a lot more cleanly. You see these big blue jagged marks here. Okay, so we can resolve that. And as I say, these two little blue sections here are something that we also want to deal with. So to deal with those little blue sections, this is quite simple. We can just set up a new 3D finishing plane. It doesn't have to be very, very big. So if we just look at the exact area that we need, which is just this little segment here, and if we go to job assignment, we can now draw a polyline specifically describing the exact area that we'd like to clean up, which I believe this should cover the majority of. So if we just highlight that for a second, and yeah, you can see that should do a nice job of it. And we also want to do this one as well. So there we go, that's where we need it to be. So we'll define another polyline here. And that should hopefully cover everything that we require. So let's just check. And yes, perfect. Okay, so the important things to remember, especially when drawing a lot of polylines on here, is to make sure to deselect the tool afterwards, because otherwise you'll start drawing errant lines everywhere, which is a bit of a pain. And we now need to define both of these curves as the job zone. Interesting, I only had one curve selected there, so let's find out what the second spline is. So the first one, oh no, it maintained the selection of both. That is strange. Okay, so the next thing that we need to define is we want to define our bottom level. So I'm going to select, this plane and click on bottom level because that's the lowest we want it to cut to. So under strategy, we can now look at what that height is. We only need to take 2 or 3 millimeters down. So realistically, we can set this to, I don't know, 64, and that should be absolutely enough. I'll also turn on scalloping for 0.1 of a millimeter, just to be absolutely safe. Now we can also adjust the angle at which we're cutting as well, just to give our cutter the best fighting chance of getting in there. So I am going to rotate this by about 90 degrees or so, just to try and approximate the best usage of space there. So that should be absolutely fine. We should now be able to generate the toolpath, and hopefully toolpath is empty after run. Of course, we didn't set the 6th axis control. Set that to fixed vector and then regenerate. And there you go, we now only have 2 small areas that are being machined. Although for some reason it's not bothering with the second one, which is not ideal. So it may be that we need to change the angle of that slightly. So if we scroll that around a little bit, so my main concern is that we don't want any of the movements or motions to be too short, because if the shorter it makes them, the less chance it has of completely covering the area. So we regenerate that toolpath now. Okay, it's still only doing that first one. So if we very quickly simulate this just to see what it comes up with, slow it down a tiny bit. And yeah, so it cleans up this area perfectly well. It doesn't bother cleaning this one up though. So what we can do to force its hand is we can actually duplicate this toolpath and then just move this region into the second toolpath. So that may end up resolving our problem. It also means that we can adjust our angle accordingly if we need to as well. So we click on duplicate, and in this one we delete the first geometry, and in this one we delete the second geometry, and we recalculate both of these. Excellent. Okay, that should be absolutely fine. And we can now simulate both of these from where we are. So slow this down. There you go. So that's the first one. And now we have the second one being machined away, which is perfect. So that should give us a much cleaner surface finish there. And you can see how there's a tiny amount of pale blue, but nothing serious there. And bearing in mind the pale blue is only, well, 0.01 of a millimeter difference. So overall, that's pretty good. Now, finally, I would like for us to try and clean up this edge a bit. Now, there's a couple of different ways we can try and approach it, but I'm going to go with the simplest and the least likely to go wrong. And that is going to be using a 3D contouring path just to follow this curve up. That's it, nothing more. Okay, because as soon as we start following it down, we start running into compensation issues, which can lead to gouges of the part. So if we go to Add Operation, 3D Entry, and 3D Contouring, we can now define this curve as the curve that we're after, and we want to make sure that there's the offset defined here as well. So when we pan over to the top, we can see that that line is now offset from here by half the tool width. That's great. The next thing that we need to define, so as to avoid any kind of gouging issues, is if we go into strategy and we set the bottom offset of this as well. So I'm going to set this to 1.5 millimeters. Which should give us just enough clearance to be able to make a very nice, quick, clean scoop of that. Okay, so we'll go back to Setup, and define the 6th axis control to fixed vector, and press Generate. And with a little bit of luck, hang on, we've got our first problem here. What's this reporting? Contact with workpiece on rapid feed. Okay, we know how to deal with this. So if we go back to the links menu, and we set engage to by arc, it should swoop in and out nicely on that. We don't need to bother with dealing with the radius of that or anything at this stage. That should do us well. I'm also going to, actually no, I'm going to set that by line because I would like it to come off and on nice and cleanly. Okay. So we should be able to recalculate that now, and hopefully we won't run into any problems. There's none indicated there. So if we simulate this now, we'll run this nice and slow just to check. We'll click on Run. You see the tool coming in here now. Okay, so that now comes in, and all it's doing is just scrubbing off those spurs there, nothing more. Okay, because this is already fairly close to final height, and we're not going to achieve a perfect result with a ball nose finish, because again, that really is something that wants to be handled at a different approach. But for scrubbing off as much material as is possible to try and minimize that load going forward, I think that's probably about the best result we're going to achieve with this. So we'll wait for that tool to figure out where it's going now, and once that's finished we should get a green node there, which is great, and with the verify compare we can see that the vast majority of this is now green and clean. This is about as close as we're going to be able to get to completely finishing a project on this kind of a shape. So ordinarily this sort of form would be done probably with more 5-axis motions, but we have managed to stick entirely within 2D and 3D operations throughout all of this, which I'm hoping has highlighted the versatility of these operations to you, as well as illustrating just how powerful some of the tools for being able to fault find and troubleshoot ENCY provides us with. So I hope this has been informative and helpful for you, and I shall see you in the next video series. Take care.